Hello and welcome to Learning Target 15 Day 1 Rate of Change. So our essential question of the day is how do we find the rate of change and how is it interpreted? So let's jump right in and talk about the rate of change. The rate of change is a ratio of two changing values. So some examples are dollars per hour and miles per hour. How do we determine if the rate of change is constant given a table? We determine if the rate of change is constant and interpret its meaning. So we have some steps to complete this. So what steps should be used to determine if it's constant? The first step we do is find the change in y and the change in x. So if we go back to the hockey scoring example, from the first to the second, the change here is +2, and the change here is +2. That's for the y values. Now let's take a look at the x. From the first to the second, we have +1, and from the second to the third, we have +1. The next thing we do is create ratios of the change in y over the change in x. So now we can write this as 2 over 1 is our first ratio. We have 2 on the right hand side and 1. So we write it as 2 over 1. And again we have 2 over 1, which is the same thing as 2. So if all the ratios are equal, then the rate of change is constant. So we got up here that both of ours are equal to 2. So that is correct. We have the ratios that are equal. So our fourth and final step in this is to use labels on the ratio to interpret the rate of change. So we have to use our labels so that we interpret what the rate of change is saying. So what this is saying right here is we have 2 goals for every 1 game. So that's what this hockey team, their average is 2 goals per 1 game. Let's try another example here. The first thing, if you'll remember, is we find the change in y and the change in x. So we're going to find the different changes in y and the changes in x. So from 25 to 80, we added 55. From 80 to 140, we add 60. And from 140 to 190, we add 50. Now checking with the x's, from 1 to 3, we add 2. From 3 to 5, we add 2. And from 5 to 7, we add 2. So now what we want to do is we want to write our ratios as the change in y over the change in x. So if you'll see for the first one, we had a change of 55 in y over a change in 2. That was our first one. Our second one, we had a change in 60 over a change of 2. And third, we had our change of 50 over the change in 2. So as you can tell, these ratios are not the same, so we do not have a constant rate of change. So therefore, we can rewrite this. We can say that we want to put it in terms of what the problem is. So we have this first ratio as 55 miles for every 2 gallons. So we are going to have these same units all the way through. So we have 60 miles for 2 gallons. And 50 miles for every 2 gallons. So let's go through in the second problem and do the same sort of thing like we've been working on. So we want to find the change in y between these values. So from 3 to 8, we added 5. From 8 to 14, we added 6. And from 14 to 16, we add 2. Now I want to go through and do the x's. So from 1 to 2, we're adding 1. From 2 to 3, we're adding 1. And from 3 to 4, we're adding 1. So now you can probably start to tell that this one will not have a constant rate of change because we have our ratios as 5 over 1, 6 over 1, and 2 over 1. So we do not have a constant rate of change in this problem. What this first one is saying is we wash 5 cars per hour, for 1 hour. This one we say we have 6 cars for 1 hour. And this is 2 cars per hour. And again, this does not have a constant rate of change. So now we're going to move on to our next subtopic here. And you can check this out on the next video.